Hello and welcome back. Where are we now? Part 5? Jesus, it's going on and on. Anyway, hopefully now we're getting into the interesting bit, which is the electronics and the circuitry and what have you. So that's where we are so far. Just bodged that in just to keep things tidy for now. Told you about that in the last video. We'll go into more detail later. At the moment, I've just knocked this up this morning. Just a bridge rectifier in a nutshell with a fuse. So a HD will go in there, rectified, positive out here, positive out here, negative over here. Very simple, just this board, what do you call it? I don't know what the board is called. It's like, I don't know. Anyway, yes, construction, very simple, very basic brackets. So here's a fuse here. Right, no, that's a fuse. So secondary comes in there and there. Positive there, negative there. I've just blobbed some nail varnish onto those two sort of tracks or whatever you like to call them there, just to for a bit of insulation, and that will sit I hope it will anyway. That will sit like that on there to keep that neat. And all we've got to do is just run a wire to our caps and everything. So let's go and get that banged in. Just before I do that, this is all sort of temporary at the moment because this plate has got to come apart probably and be painted. Well, no, it has got to come apart and be painted. As you can see, there's a bit of detail there. There's our IEC socket, dedicated mains earth with a lock. Well, it isn't a lock nut at the moment. That's just so I can get it out, so I can get it off easily. No insulation on the mains. That will come later. Same on the fuse. We'll put some insulation on that later. It's all a bit sort of temporary at the moment. Anyway, I'll go and bang it in and then we'll probably fire it up, I think. Well, that's the bridge rectifier installed. The bridge rectifier fuse. Left these a little bit long. I can always cut them shorter, but we've got ideal conditions for, and that's just tying them together. We've got ideal conditions for power supply stability, short leads, short leads, short leads. That's our ground. I had to just put this extension on because you can't get in there once it's put together. So obviously, I mean, it's all got to come apart again. What do you call it, this thing, choke and what have you, when I paint the back, although I can't see that there's anything really that needs going on there apart from inputs. Maybe we've got to figure out where we're going to put the inputs. Right, now then, moving on, just drilled a hole for a MJE 340 and that will go over to the, oh tits, I've done it wrong, haven't I? Yeah, I've got it going to the grid. What a nipple. Never mind. Oh, what a tit. Yeah, I'll will it, I'll will it. No, we're still not too bad. So there's a collector in the middle of that thingy, tranny. That's got to go over to cathode there. No, that's the anode, isn't it? Oh, for fuck's sake. Jesus, Mary and Joseph. Oh, I fucked up there. This is the problem, you see, we're doing things on the fly sometimes, you make a mistake. Right, so our collector has got to go to that pin there. And we've got to do the same on the other side, so this has got to come out. Yeah, never mind. You take it apart, put it back together, take it apart, put it back together. In and out, in and out. Anyway, shut up. That's one of the cathode followers partially wired up. So these here are our, going from our cathode to our grids of our 6146s. Two anodes joined together because it's a cathode follower. And two MGE 340Gs. I bogged up on the drilling the hole there, so what I did, I just popped a 2.5mm bolt in in the past I've tried to fill it. I find it easier just to plonk a bolt in. Yeah. Try to keep it really nice and neat. This is the bit that I really enjoy. All that messing about with the chassis for weeks, messing about with paint and whatever, is just, you know, preliminary. Bit like sex, I suppose, isn't it, really? Takes you a while to get there, and then the end bit's the best bit. Anyway, so now that will sit in there, and these wires here, I've got to go to these two MGE 340s. One is the base and one is the emitter. So shall, just before I neatly wire those in, yeah, I can do that, I can wire those in. And then also, when I come to wire these up, I'll put some sleeve in over here. All I've done with these two MGE 340s is just put a bit of, you know, that heat compound on the back. Right, more later. Well, that's all wired in now. Bit of a fiddly bleeding nightmare, but it's in. Yeah, just got to screw that down. And we're sorted. Hopefully. Not very happy with that bloody... Really, that's a bit of a cock up there I've made. I've got a mains right near this sodding pot. I might have to do something about that, reroute it further up. And I've got a bit of a... Oh, I see what the problem is. That's got to come out again because that's sitting on the nut of this. So that's got to be cut off. Ah, there's always something. Right, well, I've cocked up here. I've miswired the big mains transformer. As you can see, I'm getting 432 volts AC, and we're not even at 160 volts mains at the moment. So what I've done, I've cocked up, I've connected here and here. These are the secondary, the HT secondary of the, let's turn this off. These are the HT secondaries of the mains transformer. So instead of connecting it, because we're using the full bridge rectifier, I've connected it to there and there instead of to there and there. Now then, which means I've had to take the bleeding transformer apart again. Fucking hell. So, need to connect onto that and connect there and there. But while I'm thinking about it, while I was thinking about this, or, you know, what I'd done wrong, there's a bias winding from the centre tap, which is at something like 55 volts. I'm going to take a tap off that bias winding as well. Sorry, not connect on there, connect here and here, and then have this one coming out too, so that if I want to, I can increase the HT by 55 volts. If you're with me. So yep, I need to go and do that and put the bloody transformer back together once again. Alright, is that rectified? Can't see, can you? There we go. That's that rectified. However, I don't know if you can hear that. We're getting a loud buzzing from the transformer, so I just got to crank the bolts up, hopefully. Well, it's still buzzing like an idiot. Our lamp limiter is on. I've cranked them up. I've even used this bleeding great Makita, you know, impact driver. So, and it's doing that at about, yeah, I don't know. So, it's got to come off again. And this time I shall test the bloody thing before I, you know, install it. Ho ho. I'm still buzzing. At first I thought it was these two like braided wires here, which I thought were shields, and I twisted them together. But first I thought it was that. See, our current isn't going up. And we've got enough laminations. The only other thing I thought it could be is, see, we've got a few gaps here where the I's and the E's aren't quite joined up. That could do it. but I wouldn't have thought so. And I'm sure it's not a shorted turn, so I'm going to give it a smack with the hammer, try and knock these into line again, bolt it up, and then we'll see what occurs. See on the bottom here, there's some quite big gaps between the ear and eyes. I've done the top, we'll do this end now. Well, after all that, I'm scunnered. It's still buzzing. Why, I do not know. I'm pretty damn sure there's no short on the secondaries. I'm pretty damn sure of that. The only thing that I can think of is that when I took this apart to try and line these up properly, better, is that any sort of coating on the laminations has been broken, and each lamination is short into each other, creating a shorter turn. Laminations on transformers are usually coated, or as far as I know, this sort of, you see that sort of grey sort of scale on there, which as far as I know is a process when they roll the metal through the mill, because it's hot, obviously you get some sort of oxide sort of coating, which is called scale. And as far as I know, that is sufficient enough to insulate electrically or magnetically each lamination from each other. But usually, as far as I know, I mean, I'm no expert on this, as you know, laminations are sometimes coated either in varnish or a very thin sort of lacquer or something. Could it be that by taking it apart and putting it back together, I've destroyed the insulation? You see, rust is also an insulator. That's on the outside there. That could be the issue. Now then, the other thing I did think of is that if you, where's my resistance meter there? Now then, if you look at this secondary DC resistance, which is the resistance of the wire itself, half of the secondary of the HT secondary is 12.6 volts. Now that's about 300 volts AC, right? And each one is well, I can't get to the other one, but each half is the same. Now then, we've got two 110, 120 volt primaries. So what were that, 13 volts, that HT? Now look at the DC resistance, 2.4 volts. So part of that can be explained away because the primary is obviously going to be thicker, of a thicker gauge. Oh sorry, can you see that? 2.3 ohms. Part of that can be explained because the primary will be made of thicker gauge wire and hence will have a lower DC resistance. Still, that's a big difference, isn't it? So that's a big difference. We've got 13 ohms through a 300 volt winding, and if we combine those two 120 volt 110 windings, we've got, let's call it 5 ohms. 13 ohms, 5 ohms, that's a 7 ohm difference, isn't it? Well, 7-8 ohm difference. Puzzling. But then and again, the bugger worked. After, I'd bolted it down. So I'm scunnered. Not very happy. I mean, I've taken this apart and put it together. How many times is it now? A lot. So the solution is either to take it apart again, and if he thinks that could be an issue, recoat all the laminations, or rewind the transformer again, particularly rewind the transformer, or buy another bugger. And yeah, I don't know, I haven't got the cash at the moment to buy another bugger, so I don't know what I'm going to do there. but that means that the 6146 amplifier is on hold for that. I mean, we've got a few little gaps there, but no, that shouldn't cause that buzzing. Oh, and by the way, just to eliminate one final possibility, I did make sure that I had connected the primaries correctly. Well, it's a puzzler and no mistake. I've no idea why this transformer has suddenly started buzzing, even with the bolts done up. Previously, when I first tested this transformer before intending to use it for the 6146 amplifier, I tested it, it buzzed at about 200 volts, put a load of bolts on, clamped it up, and it was okay. I could then continue to raise the voltage to 240 volts and it worked. Then I took it apart to square the laminations up, it started buzzing even despite being bolted up. I still think the primary winding is a low DC resistance. I haven't tested the inductance, it might be instructive, but it still doesn't get us out of our trouble. So I've looked online at Hammond and other transformers, finding one of the correct secondary voltage and what have you in the right size. No, Hammonds are either too big or whatever, but I did find one on Primary Windings, which is a UK transformer winder, for about 115 quid, which is a possibility, although I ain't got 115 quid to throw at it at the moment. So I either rewind it or buy another one. So I'm going to look into that, but in the meantime the 6146 amplifier, unfortunately, just as it was starting to get interesting for me and hopefully for you as well, has had to be put on hold. So that's a bit of a bugger. I don't know, such is life, such is amplifier building on a budget. That's just how it goes. Well, thanks again all of you for watching. Take care of yourselves out there. Ta-da for now.